My name is Rich Quattrini. I'm with the Integrated Demand Resources Group of Johnson Controls. We are a group that works on connecting our customers and connecting buildings to the grid. And what I'm going to talk about today is how to leverage demand response to increase your bottom line, to put your buildings to work for you to actually make money and help the grid. So I don't know if you know what demand response is, but demand response simply is a method to encourage consumers of electricity to reduce their consumption in times of peak demand, high wholesale prices, or emergencies. And it's pretty simple. Typically a customer will receive a signal from a utility or grid operator. They'll cut back loads, and they get paid for doing that. Why do we do this? It helps the grid operator maintain reliability, helps them control prices, and the participants in demand response earn money for their efforts. So I'm going to show you a couple pictures of why this happens. Why is demand response important? Why would a utility or grid operator want to do demand response? This represents the peak load in this grid area right here around Philadelphia for last year. And this is every single day of the year with the peak hour. And what you notice is most of the times during the year, the total load on the grid is actually quite small. For only a few days does that load get above 90% of the peak demand for that grid for the year. What does that mean? Well, that means the grid operator here has to make sure there's enough generation resources to meet this peak demand plus more. So they're building generation to try to meet that peak, whereas most of the year that generation is not needed. So there's better ways to deal with this problem. You can use demand response, where you can get customers to reduce load on those few days where you get above that line and avoid building a lot of generation. That's one of the main drivers for demand response. Another driver is to mitigate prices. In open markets like we have here in the Philadelphia area, the whole mid-Atlantic area of the US, there is an hourly wholesale power market. These are the prices that people are paying generators to put power onto the grid. And on a hot summer week in Philadelphia, you can see we have a customer's typical retail rate might be 8 cents a kilowatt hour, but the wholesale power market prices are fluctuating sometimes much greater than that. So that means as stress comes on the grid in these hot days, the cost to put electrons on the grid is more than customers are paying for. That represents an opportunity in demand response to reduce loads in those hours and make money proportional to those higher prices. A third need, which is a really big one, and I live in California, this is becoming a real big need for demand response, is the fact that we have all these new renewables driving energy in the state. Renewables are great, but they're intermittent. You can't control when the wind blows, you don't know when clouds are going to roll over your solar farm, so when a grid operator utility expects to see something that looks like this, and they get back this, it causes some problems. So we're looking at demand response and having load respond to help smooth over those peaks and valleys. So those are three driving needs of why people are doing demand response. What's in it for building owners and operators? The best thing is you get paid. There are programs around the country and in certain parts of the world where customers are incentivized to reduce load on these peak hours. It helps to avoid blackouts. If we can get to that high level of consumption and get customers to cut back, you can avoid a blackout which could have even worse consequences than you'd want. It's socially responsible, you're helping the community, you're helping solve a problem, helping to build less generation, sustainable in that regard, and now you can earn LEED credits for demand response. If you automate demand response, put it in your facility, you can get LEED credits for doing that. And most of all, it funds other initiatives. You can take this money that you're making in demand response, put it back into your facility and get that money to work for you. We like to call this the virtuous cycle, where customers are earning money, they reinvest it, they implement new measures, they earn more, and this cycle continues so customers can really take the most advantage of that cash flow. There's several different types of demand response programs. The most basic is known as an emergency standby program. This is where customers are on standby to reduce load a couple times a year for grid emergencies. Very easy to do, very low touch. Most of the time they're doing nothing, but they're getting paid to be on call and ready to reduce that load. There are price response programs where there's hourly prices or dynamic prices that customers respond to. If you saw Clay's presentation earlier this morning, he talked about Georgia Tech reducing prices to dynamic signals. We have some shorter term programs called spinning reserve and frequency regulation where customers are responding very quickly to signals on the grid. In the case of spinning reserve, within 10 minutes for very short periods of time, and frequency regulation where customers are almost connected directly to the grid, responding to 2-second signals, moving their load up or down to help solve some of those problems. Program availability varies depending on where you are geographically, where you live, what your utility does, what the state rules are, who the grid operator is. There will be certain programs that you can engage in. Some you can do through a third party, some are directly with utilities, some are through the grid operators. The most basic one I talked about is that emergency program, and customers are on the hook basically to reduce their load to a specified amount during the year. When they get called for an event, in this case between 4 and 5 o'clock, they drop their load below that certain point. For that commitment to do that, they get paid. In this case, a customer earned $54,900 for that commitment to reduce load for emergencies. Price response is very popular in markets like the one we're in right here, where we have a wholesale market that supports this type of pricing mechanism. What this graph here represents is a customer's baseline load. This blue line is what they expected to use for consumption. The gray line is what they actually used. And these bars on the bottom are the wholesale market prices. So those are the prices, the hourly prices that demand response paid for those hours. So here's a customer that saw the prices were going to be high in the afternoon. They made a decision to pre-cool their building. They leveraged their building automation system. They raised their load up, got the inside of that building nice and cold. So when they got to the afternoon, they could reduce load below their baseline and then get paid for all the hours in which they cut that load back. So this helps the grid and it trims those peaks and it helps that peakiness of the grid. And in this case, the customer made $992 for their efforts for that day. Automated customers can be very active in those programs, and if they're leveraging building automation systems, they do this on a daily basis, sometimes every hot day during the summer. Here's an example of a small college right here in Pennsylvania, about 10-15 miles away. Only a 3 megawatt peak load, but you can see they engaged in June, July, and August for a total earnings and savings of about $12,000 just by being active in managing their demand response. In this case, a Chicago high-rise, much bigger building, a 12 megawatt peak load, very active in the market, and even in the winter season where they're using electric heating to cut load back, and for those guys, a total benefit of almost $114,000. The other program I talked about was Synchronized Reserve. This is where customers are dispatched 10 minutes in advance for very short durations. These are to control ramp-ups on the grid where generators are ramping up very fast, but they can't ramp up fast enough. So we have load kind of step in, reduce a little bit to help meet that ramping need of the grid. Strategies for demand response don't have to be really complicated. We have customers with very complicated strategies, but some are very simple. It could be as easy as turning off some decorative lighting, turning off fountains, just adjusting your temperature set points a few degrees in your facility. A little more sophisticated is adjusting fan cycling or deploying VFDs. Chilled water loops for large central chilling plants are a great place to look for discretionary load. Some hotels will cut elevator usage back, or big office buildings will shut down a couple elevator banks. Dishwashing is big in the hospitality industry, especially in the afternoon. If you have a restaurant and a hotel, customers are cutting back their dishwashing, moving it to a different time to avoid those higher prices. So the bottom line is you can put your buildings to work, earn money, and you can help the grid. In areas that support multiple programs, like Pennsylvania here, there's several things you can do. You can do emergency response, you can do price response, and you can even do synchronized reserve or frequency reserve to increase your total piece of the pie and put your buildings to work for you. So that's the story of demand response.